Hello, my name is Ben, and I'm a Palantir trainer at Ontologize. This is a companion video to a course on learn.palantir.com called Deep Dive, Transform Your Data with Code Repositories. Before we open things up, our CEO Taylor has a quick message for you.
Discover how Palantir customers unlock more value from Foundry and AIP thanks to our live instructor-led trainings. We are Ontologize, a group of former Palantir engineers who love teaching. We've trained thousands of Palantir users at leading organizations around the world. Unlock the full potential of your Palantir deployment by going to ontologize.com.
There are two ways to transform data as part of a production data pipeline in Foundry. If you prefer to develop without code, you're going to use Pipeline Builder. If you prefer a code-based approach, you're going to use the Code Repositories application. In Foundry, a code repository is a web-based integrated development environment, or IDE, that lets you write transforms in a variety of languages with Git integration, access to compute profiles, and a variety of other common IDE features. Although we're going to be using PySpark with Foundry APIs, it's not a course on how to write good code. It's instead an opportunity to practice with a minimal version of its most common development pattern. Before getting started, you'll want to review the course sections titled Overview and Setting Up Your Project and Folder. These are common sections in most of Palantir's online learning portal, and they'll help you understand how your permissions are going to impact your experience in the course and offer some guidance on where and how to save your training resources. Now, I'm inside of a project where I have an editor role. That means I can add artifacts in here, delete them, move them around, and that's what you'll need. Your particular Foundry environment might have a specific way of doing that. I just have a project called My Data Project, and as you can tell, I've got some things in here from previous trainings. Once you're inside of your project, create a project-specific folder by going up to the upper right corner, click the green New button, and the top option here is Folder. Let's click Folder. And then Palantir recommends that we call this Code Repo Training. Hit Enter so that name sticks, and then we're going to just open up that folder. It's going to be blank. And the next thing we need to do is actually download the data sources from learn.palantir.com, upload them as datasets so that we can transform them. This is the page in the course where you're going to go and download the data sources. You have something called claims. These are insurance claims. And then you have policies. In this course, you're going to act as a claims handler at some global insurer. And your task is going to be to brief the CFO on annual results by line of business. So you're going to use a code repository to transform the data. You're going to process two data sets. We have the historic claims, and then we have the related policies. Simply clicking on these is going to do the job. So click, that will download it to your local machine. You might want to give it a name that's recognizable. It might try to save the file with a convoluted name like you see on my screen here. I'm going to say claims raw .csv. I'm just going to put it in my downloads folder. And same thing with policies. Once you have got those, head back over to your project folder and we will upload them. Back in your project folder, a little more housekeeping. We're going to add some more folders for organizing our assets inside of the Code Repo Training folder. Upper right corner, green New button. Folder, and we're going to add a folder that actually stores the data sets, and we're going to call it data. Let's click into the data folder. We're going to create some subfolders inside of data. We're going to create a folder for raw, meaning unprocessed data that has arrived from some source. In our case, it'll be a hypothetical source because we'll be uploading them from our machine. And the other one is going to be called folder, we'll call this one prepared data or processed data, cleaned data. The term for it in this course is prepared. We're going to place the raw data sets inside of the raw folder. So go ahead and click into raw. So go ahead and open your Windows Explorer or your Finder window. Go to the folder where you downloaded those CSVs, and we're going to drag and drop them. You can select both of them at the same time. You can drag them into the screen and just let them drop. A modal will pop up. Click the upload button. And it'll upload policies raw and claims raw. Once it's done, you can click the Done button, and now we have two data sets. The course doesn't have you do this, but you can click into them. inspect the data sets themselves, we see that they have a schema, they have rows and columns. Let's go create a code repository where we're going to write some PySpark code to take these raw data sets and transform them into cleaned, prepared outputs. If you did click into this data set, we're going to go back up to the containing folder. In fact, a couple hops up. We're going to go into the code repo training folder. It's the project folder for the training course. And we're going to create yet another folder. We're going to have a folder that contains the logic or the code repository. Inside of your course folder, we're going to click the green new button and let's click a new folder and we're going to call this logic. Once you have created it, click into it and we're inside and we're going to add our code repository. Finally, let's go to the upper right corner, green new button. As you can tell, that's where we go when we want to add new things inside of our project. And we're going to look for code repositories. Click code repository and we get a wizard. This is a setup wizard. Code repositories are versatile. You can create them for a variety of purposes. We're going to transform data. When you want to transform data, you're going to choose pipelines from the other available options. Pipelines. It asks you what language you want to write in. You can create a code repository with multiple languages, but you start with one at least. We're going to choose Python. And we're going to name this. I would suggest potentially prefixing this with your name. You have some colleagues who will likely go through this course as well and create identically named assets in Foundry. And you might want to search for yours specifically. This is one way to make that search a little bit easier. So your name, claims, transforms, and in parentheses, Python. It also gives you an option to open this in VS Code, which is the recommended approach, or open with code repositories. We are going to choose open with code repositories because that's what the course recommends. If you do like working with VS Code, that's also an option. Let's stick with code repos. We're going to click initialize repository in the bottom right. This is going to bootstrap the repository with all of the artifacts that it needs in order to transform data. This screen is going to pop up and give you an option. Do you want to process this with Spark, or would you like a different execution mode? We're going to bypass this. We're going to start with a blank repository. It's effectively going to use Spark behind the scenes. Bottom right, skip and start with the blank repository. Folder structure opens on the left side of the screen. If you follow the folder path down, you'll find a folder that says Datasets. And inside of Datasets, we're going to choose to add a new file. There is an examples.py. This is some sample code. It's all commented out, so not doing anything. Inside of the Datasets folder, if you click onto Datasets, we're going to go over to the right side and click the three dots. And we're going to choose New File. Let's call this Claims. The file extension, we have a few different options. We're going to choose .py, Python transformation. And click Create. And we have the basic structure for a fundamental transform with Python in our code repository. Basic structure is you have some import statements. You have a notion of what is the input and output dataset or datasets. It's wrapped in something called transform_df. A little bit out of scope for us here, but the short of this is that it is a decorator. And then we have the actual compute function down here that takes the input, processes it, and generates the output. So we need to define the output and the input. Let's start there. If you do get this orange banner across the top, this is safe to go ahead and merge in changes. You'll notice that the output here is a generic folder path. Let's talk about the structure of this folder path. The first item in the folder path is your namespace. And then you have your project. Mine, in this case, is called My Data Project. Yours will very likely be called something different. I also had an intermediate folder here called Palantir Tutorials, in which I placed my code repo training. You may have a shorter path, logic, datasets, and then claims. What this means is that when the code repository writes out the new data, it's going to write out a data set that's just called claims. If you wanted this to be called claims clean or claims prepared, you could name that here, claims_prepared. The course doesn't have us do any specific naming there, so we're going to leave it. The input, you have a placeholder that says source dataset path. Now the course walks you through one way of finding the input data. We're going to look for claims raw. What the course has you do is come up to the top left of the screen and follow the folder path back out, go open the dataset, grab the unique ID for it or the path for it, and then place it in here. That is certainly one way you could do this. I'm going to show you a couple other ways that are a little bit more convenient. You don't have to leave your code repository. One thing that you can try here is double-click on source dataset path and just delete it. And then simply type the word claims_raw. Now it could be that your environment has multiple instances of claims_raw. For example, my colleague Josh, he was doing this training recently. He has something called claims raw. I happen to know this top one is mine. If I hover my cursor over it, I see the full folder path there. That's my project. This is one way that I can directly reference that input without having to leave at all and just typing in the name of the data set. If you have a distinctly named data set, this is going to make this method a lot easier. I'm going to Control Z and go back to where we were. Here's another method without leaving the repository. Bottom left of your screen, you have a Foundry Explorer. This is the Foundry file system, accessible as a panel at the bottom of the screen. And what I can do in here is look for recent files. There's my code repo training, data, raw, and there's claims. When I click on it, I get a preview of the data. I also get the metadata about that data set over here, which includes, among other things, the RID. An RID in Foundry is a unique identifier for a resource in Foundry. It's called a resource identifier. And if I copy that resource ID, I can replace source dataset path with the resource ID. It identifies it immediately as claims raw. I can click it, and it renders that resource ID as claims raw of the dataset. In fact, it's even hyperlinked. You could go over and you could look at the claims raw dataset by clicking that hyperlink. You can then close the Foundry Explorer window by clicking it in the bottom left. So you don't actually have to leave your repository to make this work. So if we look at how this code is currently structured, the input is aliased as something called source_df, df here, short for data frame. And this compute function is taking in that source df and just returning the source df. So it's taking in the input and just passing it directly through, not making one single change to it at all. But we can still preview it. Upper right part of the screen, you'll find a preview button. Go ahead and click preview. And what preview does is it takes a subset of the inputs, it runs it through your logic and gives you a preview of what the transformed data is going to look like. It doesn't actually write anything out to disk, it just shows you what the data set will look like. There we go, input transformed into the previewed output down below. While we're here, check out this date column. The date is a string type. Already that could be a problem. And then we look into that string and we see there's plenty of things for us to clean up here. We have these pound signs or hash symbols around the date. We're going to need to clean that out and potentially cast this to a date. There may be some other things to transform in here as well, but at least we see certainly one thing that we want to transform. I neglected to do one step in the process, and that is to change the folder path for the output. If I were to build this now, it's going to write out a new data set inside of Code Repository Training, Logic, Datasets, Claims. I would rather it send the data, instead of into Logic, I would like to go into Data, Prepared, Claims. If this path doesn't exist, Foundry will build it. It will build all the folders. I could add 10 new folders in here, and it would build all of them out and place the data set in the last folder. Also, watch what happens if I remove claims and I backspace. Foundry is aware of the folder structure, so it knows in your code repo training, Ben, you have a folder called data, you have one called logic. What would you like to put here? And I could click data and find prepared. And then hit enter,
It has the folder path, and then at the end of that, I can click claims. The point here is that you want to make sure that you're landing the claims output into your data prepared folder. If yours was capitalized, make sure you have the capitalization. Foundry will treat capitalized folders as different from non-capitalized folders. It's now time to actually clean this data. There are two things that we're going to do. First, let's clean this date. We've talked about that. And then the other one here, these are claims. And there's a Boolean column here for is accepted. And we want to filter on that column. Those are the two things that we're going to do in this step. The course page conveniently has what the code currently looks like and what the code will look like at the end of the steps. I'm not going to take a lot of time to talk about the logic of the PySpark code that's being used. If you would like to understand the syntax more, there are resources online for understanding the PySpark APIs. We are just going to go through the steps one by one. So I am on step 1, import functions and types. Very top of the screen, you have a commented line. It's from PySpark.SQL import functions as if. We do want PySpark SQL functions. That's going to be handy for us. It's a pretty rich library for interacting with data with PySpark. So we're going to remove that comment. That's all we need to do is just hit the backspace and remove that comment. How about just after that, we're going to import something else from PySpark.SQL. In fact, I can just copy and then paste that down below. We're going to import types as T. You'll get a little underline letting you know you have imported these, but they're not being used. Let's go to step 2, and we're going to cast that date column. One of the things we're going to do first is we're going to change the name of this alias. Source_df, not really descriptive. Let's instead call this claims_raw. You don't have to call it the same as the dataset. I could just have called this claims. I could call it X if I wanted to. The tutorial has us enter this as claims_raw, which means that's what we're going to pass into our compute function. So we also need to replace it here. I can just double click, copy, and then paste claims raw. Just make sure that they're the same. And you'll get a red underline because it no longer knows what source_df is. Not to worry, we will take care of that. Now I'm simply going to copy the code directly out of the course page rather than trying to type it out line by line. So this is in step 2. I'm going to copy the compute function, and as soon as I paste it in here, you'll see exactly what I'm talking about. I'm going to highlight the lines that I'm going to replace. I'm just going to Control V or Command V and paste those directly in there. Again, this is in step 2, and it's sub-step number 2. It says the previous lines 10 and 11 become, and then it has our code. And we've already re-aliased this as claims raw, so this should slide in very nicely. Let's test this out by clicking the preview button in the upper right corner. It's not really the corner, the upper right part of the screen. And this looks much better. It's cast as a date, and we have those extra characters removed. Now for the next transform, we're going to filter to just those claims that have been accepted. We're going to filter out the ones where accepted is false. So scroll down in the course page, step 3, filter your data set. You can just replace all of your code from line 10 and beyond with the code that's there in that block. I'm going to just grab everything and then just replace all that code. So I just copied and then Control-C, Control-V, paste it into the repository. And once again, we can preview and check this out. We should, again, have a corrected date column, and also we should just have rows where is accepted is true. One way that we can check this directly here in Code Repositories is to, in the preview, we can come down to the is accepted column. The drop-down arrow in the column header allows us to view stats, and we can see that they are all true and there are no false values. So that transform worked. After we've been doing work in our code repositories, we notice that the folder structure is lit up. There are some orange lines. If we've added new files in here, they'll appear as green. If we have removed some, they show as red. If this is letting us know visually something has changed in your repository since you last saved it. The way that you save is by doing something called a commit. A commit is like saving the current state of your code onto the current branch, which, as you can see in the upper left corner, is indeed the master branch. When you want to commit in Code Repositories, the upper right part of the screen has a commit button. Now, if you don't see it, various screen resolutions are going to present these buttons in different ways. So you may want to change your browser resolution. Click the commit button, and you have an opportunity to enter a commit message. This is a best practice. You should always use a nice, succinct description of what this save includes. We're going to say cast and filter claims, and then click commit. When you commit, a process kicks off inside your code repository called continuous integration checks. And the purpose of these checks is to verify the state of your repository, make sure that it's consistent, that there's a container ready for your dataset to land in. So it does a variety of things. It also adds another minute or two to your development process. So we do have to wait for these checks to pass. There's a check running. Where do I go see it? A couple ways you can see it. Upper right part of the screen, there's a tag. I see a number 1, and I see some process that's running. If I click into it, it lets me know you have running checks in your repository. There's also a checks menu along the top of the screen. If I click into checks, it lets me know there is a running set of continuous integration checks, which if I click in, I can expand the Foundry published checks and watch the entire process unfold before my eyes. It's not the most interesting thing to watch, but if you want to hang out here until it finishes, it takes a minute or two, and then we can proceed. The checks have passed. I'll go back to the Code tab, into my files, back to claims, and we're ready for the next step. One of the other pieces of data that's going to be important for our reporting is the line of business associated with each claim. But line of business is on our policies raw dataset. And so we're going to need to join it in. As a shared key, we're going to take advantage of that shared key to just bring in that column that we want. So this is how to join in data using the transform_df decorator in a code repository. It's going to be a new input. So we're going to come right up to line 8 for me. This is where we have claims raw. I'm going to go to the end of that line. There's a comma. And outside that comma, I'm going to hit enter. And we have a new line, and we're going to call this policies_raw. That's how we're going to alias this new input. So the input method takes an argument, and it is the path to an input data set. We also want to put a comma at the end, even of our new line. So comma goes out at the end, and we need to put something inside these quotation marks. I showed you a couple methods for doing this. We can look for policies_raw. There's the one that belongs to my colleague Josh. Here's the one that belongs to me. I could click this and be totally fine. Another thing I could have done is I could have renamed this data set to be my name_policies_raw, and that makes it very unambiguous which one belongs to me. I can also use Foundry Explorer in the bottom left of the screen. This is the Foundry folder system is now exposed, and I don't have to leave the repository. Recent files shows me my code repo training, data, raw, and we have policies raw. If I click on it, here's the metadata, and as I scroll down through the metadata, I can grab the resource ID, which is the unique reference for that data set, and plug it directly in as the value passed into the input method. It renders it as policies raw. That's how I know that it's working. In fact, I could follow that hyperlink just to make sure that indeed it is my data set. Let's take care of the join. I'm going to copy the code just like I did before. Before I do that, however, I need to add in policies raw as an input to the compute function. So next to claims raw, I might as well just copy policies raw, the alias. I will insert a comma after claims raw and put my other variable in there. Here's where we are in the course, join in another data set. Here's the code block that we're working toward. If we copy this verbatim, these resource IDs do not refer to our data sets. So just beware, if you think you should be able to copy everything and drop it into your Foundry environment, that will fail because it doesn't know what these are. These belong to whatever system Palantir was using when they were creating this tutorial. So these resource IDs do not refer to anything in reality in your training environment. So don't try to copy those. You could totally copy the compute function. You could grab this entire compute function, just replace it. Or we could just replace the join in the policies to get line of business. Either one of those will work. So please just try one method. I am just going to grab join in policies to get LOB. And this is the claims data frame now gets claims. We're going to use a join method to join policies raw on policy ID. That's the shared key. How equals, now this is a little bit more of a verbose implementation of the join method, and that's a best practice. It almost adds another layer of documentation in your code. It is a left join on the policy ID column that's shared between the current data frame and whatever it is that we're bringing in, policies raw. Copy, head back over to my code. I need to insert this before return claims. So if I hit enter after the line just before, I can paste that in. Notice the spacing gets off a little bit and I can backspace. We just want our code to appear like it does in the tutorial code block. This looks like it's going to be correct. How do we test this? Well, if we click preview, what we're hoping to see is we now have an LOB column. So if we scroll over, we see there is LOB success. We now have a line of business value for every claim. We're ready to save. Let's commit in the upper right corner. And let's say joining claims with policies. Commit, that's going to kick off continuous integration checks again. Yes, it will rerun all the checks every time we commit new code. It looks like my checks have succeeded. Once those checks succeed, I'm ready to build. Truth be told, you could hit the build button even in the middle of checks. It will sort everything out, make sure that those checks happen before the build sequentially. But now that the commit is done, and the commit button, if you don't have anything to commit, it's grayed out. Previously, what we did was we previewed. That doesn't write anything out to disk. It doesn't create a new data set. It just presents the data as it will appear once it does get written out. We also committed, still not writing it out as a new data set. It just saves the state of the repository and runs the checks. Build will actually take the inputs, run it through the logic defined here, and generate the output or outputs defined in the transform. Let's click the build button. If you do get this message, as it says in the training, go ahead and click Update then Build. And the build panel opens at the bottom of the screen. It's going to, surprise, kick off checks. It will kick off the build, and it will generate claims. One thing you might be thinking, this sure takes a long time. What to think about here is the continuous integration checks in a code repository does add some overhead, and it's overhead that you don't get in Pipeline Builder, for example. You don't have to have those continuous integration checks with Pipeline Builder like you do in a code repository. Second, the build itself, you'll notice, probably runs slower than if you were to process it with, say, Jupyter Notebook on your local machine. And the reason for that is that we chose Spark as our compute engine, and Spark is really great for large-scale data. At smaller scales, it adds enough overhead to make it feel like it's going a lot slower. Once those checks run, the build will kick off. Looks like the build has completed. I see green check marks across the board on the left side. What can I do from here? If we click into the item in the left-hand panel, we get a preview of the data. We also have a hyperlink to claims. There's a lot of ways to get to claims from here. You can go up to the output. It now has claims. We could click into claims, be taken to the data set that way. We can also go up to our folder path, go into the code repo training, into your data, into your prepared folder. So it's hard not to go to the output. Let's click onto just one of these options. How about right here, claims. Claims, we open it in a new tab, and here's the actual data set in Foundry. Left-hand side of the screen in updated via, we see a link back to the code repository. Every data set in Foundry will have something here in updated via. This is how did this dataset get generated in Foundry? If we click on the History tab of the dataset, we can see that this was updated a minute ago by yours truly. If you click into that, this is a transaction, and a transaction is an immutable record of the process we just described. Foundry takes the inputs, runs it through the logic, and generates one or more outputs. All the details of the transactions are here. One more thing before we move on to the branching workflow. Upper right part of the screen, Explore Pipeline allows us to take this into data lineage. This is the data set. We'll take this into data lineage. We're just going to take a look here. Claims and raw. So we've seen now firsthand how these get created. Inputs, outputs, and the lines between them indicate some kind of input-output relationship here. If we click on claims and go to code at the bottom of the screen, here's our code. And we could go over to the repository. We could even make a quick edit, which allows us to make a change to the code and submit it as a pull request, which is a change request in Git parlance. So congratulations, you've just created your first output from a code repository. We're not quite done yet, though. I'm going to head back into our code repository. We've got a little bit more work to do.
Our data transforms are proceeding nicely, but we want to get this data in a different format for our presentation. What we would like to see is an aggregated average claim cost per line of business. And the way that we're going to do that is with a group by. Group by is a method available on PySpark.SQL functions. But the path there that we're going to take is to branch from our master branch, develop on that branch, and then merge that branch back into master. To fully take advantage of the steps in this tutorial, you'll need to make sure that you have the owner role on your code repository. Here's how you can check for that. Come up to the upper left part of your screen. We're going to go into we need to go up to the project level. So this is likely to be the far left item. It's the filing cabinet, not one of the files themselves, but the filing cabinet. I'm going to open it in a new tab. I'm going to leave this open so I can come back to it. Okay, here's my project level. When I'm at the project level, I can come over to the right side of the screen. There is an access button. It's a padlock icon. Click on it. And you can see what the default role is for your project. In other words, what is the role that everybody inherits when they come into your project? And then what additional roles I have. I happen to have the owner role. Now, if you need to manage this and you have permission to manage this, you can click the Manage button and you can so you can change your own role. Maybe if you are owner and you want to change it, this could give you an interface to do that. You may have to have an administrator change your permissions from editor to owner or whatever the owner-like role is at your organization. Remember that users belong to groups. Groups have roles on resources in Foundry, like projects. So you want to make sure that you've got the owner role before we proceed. If you just can't get the owner role, that's okay. You just won't be able to protect your master branch, which is the subject of the first lesson in the collaboration via branching chapter of this tutorial. So I'm going to go back into Code Repo Training, Logic, and open our repository. Usually, in production, you will protect the master or main branch of your repository or your pipeline or whatever the artifact is. This typically represents the production grade resources that you want to make sure are protected from any changes. The only way to make changes to a master branch or a main branch of a resource that's protected is through the pull request process, which is like the change request process. To protect our branch, we're going to come up to the top menu and we're going to go into the settings for the repository. If you don't find settings, it could be your browser size. You notice if I zoom in, I don't have settings. It's collapsed under the More menu. One way or another, you'll find it, Settings. And we're going to come down to Branches. One of our options in the Branches submenu is to protect branches. And we can choose the branches that we want to protect. So let's go ahead and protect the master branch if you can. Click the drop-down. Let's click Master. Here's where we can set the terms for the protection. We have a number of options, but the tutorial just has us leave these defaults. We'll click Save in the bottom right. We have a padlock now next to the master branch, if we head back to the code tab at the top of the screen, we can see that the master branch is protected. If I click in to the editor and try to type, it tells me this is read-only code. If you want to make changes, you have to branch. If you weren't able to go through that workflow, you're at least aware you've got to have an owner role, and now you know how to actually protect the master branch and some of the features that are available while you're doing that. We need to create a pivoted version of our data with a group by. So let's branch from the master branch. We can branch from the master branch or any branch that we're on by clicking the Get Branch icon out to the right of the branch name. Create a new branch. It is going to be a Code Repositories branch, and we're going to branch from master. Let's call this your name. Aggregate claims per line of business. And click the Create button in the bottom right. Your organization might have its own convention for branch naming. This is the one that the course recommends. Create. We are now on a different branch. In the Performing a Transform on Your Branch section of the tutorial, you'll find some new code. If we scroll down, Create Your Transform. Here is the line of code that we want to add, and we're going to return claims aggregated instead of just returning claims. So we create a new data frame that takes claims. It uses the group by method. We're going to group by line of business, and the aggregation is going to be the average claim value. And we're going to alias this new column as average claim cost. And then we will return that data frame. I'm going to grab this code, copy, come back over to my repository. I'm on line 24, where my return statement was. If I Control V, need to fix that spacing. And I don't need to return two things. I only return one data frame with a transform underscore df decorator. So I'm going to remove return claims. It wants to eliminate some white space here. And now we have our aggregation. Let's give this a try. Preview. And that's how we would expect this schema to look now. We have our line of business and we have average claim cost. Let's commit. And when we commit, we're going to commit onto our branch. Commit. Let's call this aggregating claims. Commit. And while we're here, let's also build. The course doesn't have you do that, but I think this is a good learning opportunity. Let's click Build. Code repositories and pipelines in Pipeline Builder are branched. Datasets built on those branches are also branched. So we're going to build this dataset on this branch. As soon as it's done, we'll go take a look at the dataset and we'll see there's now two different branches of the dataset. And we'll do this before we merge it back in. This is just for illustrative purposes. You don't have to follow these steps. So we'll give this just a moment to run. Okay, that build has completed. I got a preview of it down below. This is how it looks on this branch. Let's go over to the dataset. This time I'm going to click it just right here. I mentioned there's a few ways to get to the dataset. Click Claims. I'm going to open it in a new tab so I can come back here. And this is the dataset. Looks a lot different than it did on the other branch. Upper left part of the screen, we're looking at claims on this branch. The branch name is truncated because it's pretty long. If I click the dropdown, I can now toggle between the branches. Now the differences between these branches are obvious, but if they were more subtle, I could go to the Compare tab and I could compare the two branches side by side. The schemas, etc. The code. I'm going to go back to the code repository. And our next task is to merge this branch into the master branch. The tutorial has you do a click path that works. It tells you to go up to branches, you find your branch, and you can propose changes. But in the code, if you happen to be in the code tab, there's a propose changes button in the upper right corner. You don't need to go to the other menu. Propose changes. And this is where we're going to describe our request. Pull requests usually have to be approved by somebody or by somebody on a team or multiple members of a team, especially if it's the main branch or the master branch of some important production artifact. Let's call this computing average claim value by line of business. In the tutorial, you can just grab the text from the merge your branch into master. In step 1, it gives you some text that you can just copy and paste in here so you don't have to watch me write it out. And what we're going to do is we're going to create the pull request. This is, please merge my code in. I'd like this to be the master branch code. It's a pretty dramatic replacement of what was there previously because we're doing that aggregation. Create pull request. On the pull request page, which we and members of the team who can approve the pull request will be able to see, we have some tabs across the top. What files were changed and in what way? If you go to pipeline review, it lets you see you do have a data pipeline. This is not data lineage, but it looks like data lineage. It's data lineage-like. And it lets you know you have one item in this pipeline that's going to be affected by your code. And there's one commit in this pull request. Approvers of your pull request will have a few different options. They can delete the branch when it's merged. They could set this to automatically merge once the continuous integration checks have finished running. They can squash and merge. They can merge with fast forward. These are Git-specific terms. If you're interested in the details, please go look them up online. We're going to use squash and merge. And then click squash and merge. It shows as merged. We can go back to the code, and we're on the master branch, and there is our aggregation. It's still not built yet. That would be a subsequent step to then go and build our dataset on the latest commit, which includes new code on the master branch. Let's click build in the upper right corner. We've done this a few times now. We know we have to wait for continuous integration checks, the build process, which in our case includes a Spark application that has to be spun up and be made available to us and then execute, and then write out the dataset to disk so that we can access it in the Foundry file system. Build is finished. We could go look at the dataset now. We can also go look in data lineage. In fact, that's what the tutorial has you do, is go to data lineage. We've already got a data lineage graph open. We didn't save it, so we could rebuild it here by going up to the upper right corner. There's a data lineage button inside of your code repository that's going to take all the inputs and outputs across your repository, put them onto a data lineage graph. This is kind of a quick way to visualize everything in your repo. There's claims. We can show the two hidden parents, and there we go. Also, in data lineage, because we have data assets that were built on multiple branches, at the top of the screen, we can toggle between those branches, master, and then here. Now notice these claims raw and policies raw, they don't have this B. Thomas aggregated claims per line of business branch. And so they're using something called a fallback branch, which means if you can't find this branch upstream, then fall back to some other branch, and master is the default. Congrats on completing this deep dive. If this was your first experience with PySpark, double congratulations to you. We hope you had a good time. And most of all, we hope you feel comfortable, or at least more comfortable, working inside of the Code Repositories application.